Hi, I'm Jake, an engineer at Rollon.
And I'm Fred, territory manager at Rollon.
And welcome to this Rollon Tech Talk. Today we're going to give you a brief overview of the rod ends that Rollon offers and discuss how to select the best rod end for your application. Fred, Rollon offers a wide variety of rod ends, both standard and customized, that are used across many industries. What factors should be considered when selecting one?
When selecting a rod end, we should consider these 5 points: axial and radial loading, motion type, static, rotational, or swiveling, and the speed, maintenance requirements and ease of maintenance, environment, and custom geometries.
Let's start with axial and radial loading. In this case, axial loading acts into the face of the rod end, while radial loading acts into the outer diameter of the housing. How does axial and radial loading impact rod end selection?
Rod end design varies depending on if it's intended to accommodate axial, radial, or combined loading. The housing material, bearing type, and raceway material need to be strong enough to withstand application loads, and they need to be selected carefully to ensure the rod end will have the operating lifetime that the application needs.
So, for example, a rod end with a stainless steel housing and a low friction raceway may not be a great option for an application with very high load conditions.
Right. For a high load, we'd recommend a heavy-duty rod end. We'd still use a spherical plain bearing or a straight bearing, but the bearing material would be something stronger, like steel or bronze. We've got various options available for this in our classic, Teskubal, and premium lines.
Okay, now the second point to consider is the motion of the bearing in the rod end. It could be rotational or swiveling or static.
You'll need to pick a rod end that provides enough freedom of movement. For applications with slow motion, a spherical plain bearing is fine. Spherical plain bearings can also be specified to offer a very wide swivel angle, so they're useful for applications with high angular misalignment.
Now, what about applications that require the bearing to turn at very high speeds?
Ball bearings or cylindrical roller bearings are used in that case. Our premium series rod ends come in ball and roller bearing versions, and they're DIN ISO 12240-4 compliant.
Do rod ends degrade over time?
Yes. As the sliding surfaces wear, a gap may begin to develop between the bearing surfaces, which creates backlash. Our engineering team reviews the duty cycle and lifetime requirements of the rod ends we recommend to make sure unexpected issues won't develop over time.
The next point is maintenance. What do we need to consider here?
Depending on the load and duty cycle of the application, a maintenance-free rod end may be suitable. Those feature a self-lubricating liner made of another lubricant-impregnated material like polymer or sintered bronze. If those lining materials can't be used, like in a ball or roller bearing in a premium line, the rod end includes a lubrication system to inject lubricant on a regular schedule.
The next point to think about when selecting a rod end is the operating environment. What parameters need to be considered here?
The next parameter to consider is operating temperature. This can vary widely, so our premium, classic, Tesno, and basic rod ends have max operating temperatures from 60 to 200 degrees Celsius. For the highest temperature conditions, where traditional lubricants will degrade, our Teskubal line is available with self-lubricating sintered bronze. In dusty or contaminated environments, rod ends that tolerate particle ingress should be selected. Either sliding type or sealed bearings work best here. When corrosion or humidity is present, or for medical or food and beverage environments, rod ends can be made of corrosion-resistant and washdown compliant materials like stainless steel.
Finally, for special configurations or non-standard geometries, what can we offer?
For special requests, our engineering team can develop custom solutions. For example, we can provide rod ends in various materials, diameters, lengths, thread connection types, and configurations, including linkages and subassemblies.
Okay, we've discussed a lot of factors of rod end selection so far. What tools do we have available to simplify the design and specification process?
The entire Rollon rod end portfolio is configurable on myrollon.com. The selection tool allows design engineers to consider loads, working conditions, and dimensions to compare and select the rod ends that are best suited for their application.
For more information on Rollon's portfolio of rod ends and rotational products, or to get in touch with a Rollon engineer, please visit rollon.com. Thanks for watching.